Hi, everyone, and thank you for joining this session today. My name is Bhaskar Sawant. I work as a team lead and full stack software engineer. I'm also an IEEE senior member with the Southeastern Michigan section. I have spent around 15 years building and improving the DevOps pipelines, automating the workflows, and strengthening the delivery systems. Over the last few years, my focus has been on supply chain security and AI driven automation, helping teams adopt SBOMs, Provenance, and SLSA so they can deliver the software that is both fast and secure. Today, we are talking about the supply chain defense by default, SBOMs, SLSA, and Provenance in CI/CD. This talk is focused on the practical security, not the theoretical framework, not the security checklist that sit in the document no one really reads, and definitely not the heroics that depends on the individuals remembering to do something manually. Instead, we will look to how to build supply chain security directly into the pipeline so that the secure path becomes the default path and the developers are not slowed down by the security controls. Security becomes a natural outcome of the way system work. The landscape of the software security has shifted dramatically. 10 years ago, attackers focused mainly on the application level issues, SQL injection, cross-script scripting, misconfiguration. But today, they are going upstream and attacking the software supply chain. They are targeting open source dependencies, package managers, CI/CD building systems, artifact repositories, and the automation that ships code into the production. Modern DevOps pipelines move fast, which is good, but fast pipeline that lacks transparency or verification can become the blind spot, and attackers love blind spots. In many organizations, CI/CD becomes the most trusted system, but ironically least verified. Recent incident shows us why the supply security chain is urgent. SolarWinds wasn't an application vulnerability, it was the build system itself being compromised. Log4j wasn't a failure of application code, it was a failure of visibility into the dependencies. And the XZ backdoor showed us that even a long term open source maintainers can become attack vectors. These are not isolated cases, they are part of the pattern. All of them teach the same lesson. If you can't see what your software supply chain, you can't secure it. Security teams were blindsided not because the vulnerabilities were impossible to address, but because they lacked visibility, traceability, and the proof of where the software came from. So, what does defense by default means? It means building security into the pipeline so deeply that developers don't have to think about it. Security is not a separate process, not a afterthought, not a manual approval. It's simply how the pipeline operates. Every bill automatically generates the evidence which needed. Every artifact carried carries the metadata that proves it's trustworthy. Even the deployment is verified by the platform itself, not by the person. When the security is by default, it becomes the consistent, predictable, and scalable. And the developers can stay focused on building, not policing. SBOMs, software bill of materials, are one of the most effective tool in the supply chain defense. They are basically ingredient list for your application. They tells you exactly what's inside your code base. But here is the important part. An SBOMs only works if it's generated automatically on every bit and stored with the artifact. When vulnerability hits log4j, you shouldn't have to scramble. You should be able to instantly answer, are we affected? Where are we affected? Which versions are impacted? Organizations that had the SBOM generally generated automatically handles the 4J log4j in hours. Organization without SBOMs spend days, even some weeks, just figuring out where to start. This is why the SBOM aren't just paperwork, they are operationally life-saving. Provenance answer the critical question. Can we prove how this software was built? It's the full chain of custody of an artifact. Who builds it? When it was built? What source code it used? What pipeline executed it? And what environment it ran on? Attestation are simply the signed proof of this information. This stops attacks someone inserting a malicious image into the registry, a developer pushing a local build by accident, or the compromised CI runner injecting something harmful. If provenance is missing or incorrect, the artifact should not be deployable. And that's not something human should decide. It should be automated and enforced by the system. The SLSA framework gives us a path forward. You don't need to start at the highest level. You start where you are and mature over time. You begin by ensuring the builds are logged, then you ensure builds run from the version control scripts, then you add provenance signing, and eventually you reach the hermetic reproducible build. SLSA is not about perfection, it's about making each link in a supply chain stronger. Even small improvements make a big difference. Once we begin strengthening the pipeline, several important controls comes into play. First, keyless signing. CI pipeline generates temporarily identities instead of relying on stored private. Imperiled runners build environments are destroyed after each run to reduce the long-term compromise. Immutable artifacts. Once published, artifacts cannot be silently swapped or replaced. Deployment and verification. The platform checks signatures and provenance before allowing the deployment. This means the system, not the humans, validates trust. And that's the only scalable way to secure the modern delivery pipeline. Run in isolation, with no network access and no ability to face the unknown dependencies during the build. They rely on a pre-approved pin components. Stable builds ensures that the same input always produce the same output. This lets us detect the tampering instantly. Together, this approach transforms your pipeline from an open workshop into the control environment, where every input and output can be verified. Dependency hygiene might sound simple, but is one of the most impactful things you can do. It means pinning versions, reviewing all new libraries, avoiding floating dependency versions, and preventing automated updates from bypassing security review. This keeps the unverified code from sneaking in silently. One of the most common way attackers get into the supply chain. Code dependency hygiene creates the stability and predictability. Let me share the practical example that shows how powerful these practices can be. Before implementing the supply chain defense, one team was deploying the microservices to the Kubernetes. Their pipeline was fast but not verified. Deployers could push local images into the registry, SBOMs were inconsistent, and provenance wasn't enforced. When the Log4j crisis hits, it took almost a full week just to locate the affected services. Now let's look at the after. Once they adopted the supply chain defense by default, every build was signed automatically, every artifact produced the SBOMs, Kubernetes enforced signature verification, and dependency metadata was centralized. Later, during the simulated vulnerabilities event, they identify all the impacted services in a minute. What's beautiful about this is that security improved, but velocity didn't stop. So pipeline becomes safer without becoming slower. That's the ideal balance. Deployment is a moment where the risk become real. Everything before deployment is a hypothetical risk. Deployment is the point of no return. This is why the deployment time enforcement is essential. If the artifact lacks the valid signature or provenance, deployment should simply fail. Not with an email, not with a warning, just hard stop. This prevents the accidental deployments, malicious insert, and unapproved builds. Think of it as a last checkpoint, the final quality gate before the production. One of the biggest misconception is that the supply chain defense requires a massive all at once transformation. It isn't. You start small, begin by generating SBOM automatically, then add signing and provenance in CI, test verification in staging, and once the process is stable, enforce it in the production. This phased approach keeps the delivery smooth and builds organizational. Let me add one more important piece that often gets overlooked: the cultural shift. Supply chain security is not just about tooling problem, it's a mindset shift. Teams need to move from we trust our pipeline to our pipeline proves it can be trusted. They need to move from we hope our dependencies are safe to we know exactly what we are shipping. And they need to move on from security slows us down to security done right speed up by preventing the emergencies. The real transformation happens when developers, DevOps engineers, and the security team all see supply chain defense as a shared advantage, not an obstacle. When the shift happens, adoption becomes smooth and natural. Here are the few key takeaways from our discussion. First, the software supply chain has become one of the most active cybersecurity battlegrounds. Attackers are targeting dependencies, build systems, and automation, not just the production apps. So, if we don't secure the pipeline, we can't secure what comes out of it. Second, the strongest defense is the shifting security into the CI/CD process itself. Ev- when every artifact is signed, traceable, and verified automatically, we reduce the risk without slowing down the delivery. Pipeline trust becomes the application trust. Third, the tools and the practices we discussed, SBOMs, Provenance, attestation, SLSA, ceramic builds, and the deploy time verification are not theoretical, they are practical, adaptable steps that any organization can start implementing in phases. And finally, remember this: security should not depend on a late night heroics or manual checks. It should be the default outcome of how we build the software. When we design the pipeline that enforce the security automatically, we protect our systems and empower our teams to innovate with the confidence. Before I close, I want you to leave with this. Security shouldn't depend on the people remembering the steps. It should be the built into the pipeline so every release is trusted by default. If we can make supply chain security automatic, we make our team faster, safer, and more resilient without slowing innovation. Thank you all for your time and attention today. If you have any question, you can reach me on my LinkedIn ID. Thank you. Thank you very much.